Hello everyone. In this video we'll learn about operators and operands. Operators are basically those entities which perform operation on the data, whereas operands are those entities in an expression on which the operation is to be performed. So here are the types of operators. Arithmetic operator. We've seen in the previous video there are 5 arithmetic operators: addition, subtraction, multiplication, division and modulo. Then comes relational operators. There are 6 types of relational operators: less than, greater than, less than equals to, greater than equals to, equals to and not equals to. Equals to, this operator is used to check whether both the operands are equal or not. On the other hand, not equal to checks for inequality of both operands. We have logical operator. There are 3 logical operators: logical AND, logical OR and logical NOT. Logical AND is written by 2 ampersand signs. Logical OR, this key could be found above the enter key, and this is the logical NOT. The need for logical operators arise when we have more than one relation in our expression. Whenever we have a single relation, the relational operators are suffice, and similar to relational operators, logical operators also simplify the expression to Boolean value. Whenever we use a relational expression, it will always return us either true or false. Same way, logical operators also simplify value to either true or false. Then we have an assignment operator, equals to, and bitwise AND, bitwise OR and bitwise NOT. Similar to logical, but bitwise operator operates on the bits. We will look at this particular concept in depth later on. And in the end, we have a conditional ternary operator, popularly known as conditional operator. Let us have a look at few examples. So here is a sample code from Java. We have declared 2 variables of type int, a equals to 4 and b is initialized to 5, and we have an expression ans equals to a plus b minus 6. Here a, b and 6 are the operands, whereas plus, minus and equals to sign are operators. And here we have another example showing use of relational operators. As I mentioned before, relational operators always simplify to Boolean value. So we have declared a variable of type Boolean named ans equals to 5 greater than 10, checks whether 5 is greater than 10. It's obviously false. 5 is smaller than 10, therefore it will return the value false. If there had been a value here which is greater than 10, then it would have written true. Let us try to compile this particular program. Open up a terminal, compiler javac operator1.java. Then we interpret the bytecode using Java interpreter. Wait, we have an error. There is no output. Operator 2, sorry, it's an operator 2. Compile operator2.java and then interpret operator 2. So the first print statement was 5 greater than 10, which is obviously wrong. Therefore this relation returns false and we get the output as false. And we have second relation, 11 equals to 11. This is equality check. Obviously 11 is same as 11, therefore it returns true and we get the output as true. Here we have declared 2 variables n1 and n2 initialized to 13 and 34 respectively. We are checking n1 not equal to n2, which is obviously true. 13 does not equal to 34, therefore this relation simplifies to Boolean true and we get an answer true. Here we have a relation 5 greater than equal to n2. The greater than equal to operator works by checking condition both ways, checks whether the operand on left is greater than the operand on right or both the operands are equal. So first we check 5 is greater than n2. The value of n2 is 34. 5 is greater than 34, false. Now let us check for the equality. 5 equals to 34, which is also false. If either one of the condition was true, it would simplify to true, but in this case both of them are false, as 5 is neither greater nor equal to 34. Therefore this relation would simplify to false. hence we get output false. Another thing to note is that we could use variables in relation, mixture of constants and variables, and just plainly constants. And here we have a last relation, n1 less than equal to 10. Again we check both the condition, is n1 less than 10 or n1 equal to 10. N1 is less than 10, 13 less than 10 is false, 13 equals to 10 is also false. Again the entire relation simplifies to false, therefore we get output as false. So these were the 6 relational operators. Now let us have a look at another example. Here we have a look at ternary expression. So the syntax for writing conditional or ternary expression is following. First we have an expression which has to be of type boolean. It should always simplify to either true or false. If the expression simplifies to true, the expression after the question mark is evaluated and then returned to val. And if this particular expression simplifies to false, the expression behind colon gets evaluated and then the value is returned back to val. Let us have a look at an example. We have declared two variables n1 and n2 initialized to 14 and 30. Here we have a boolean expression where relation is n1 greater than n2. n1 is 14, n2 is 30. So 14 greater than 30 would simplify to false. Therefore, the expression which would be evaluated is n2 into n1. As per the syntax, if expression is false, the expression behind colon gets evaluated. So expression behind colon is n2 into n1, which would produce 14 into 30 and it should return 420. Let us have a look at it. Compile the code and then interpret it. So we get answer is 420. 14 into 30 gives us 420. Now let us change the operator to make the relation true. 14 less than 30, which is obviously true. Then in this case we expect n1 plus n2 to be evaluated and then return the simplified value, which should be 44. 30 plus 14 simplifies to 44, which is 44. Alright, now suppose if you have a case where you do not have an expression, just simply a constant or a value, then in those cases the expression, instead of expression, the value of the variable is directly written back to the variable on left of assignment operator. So if I say n1 less than n2, return n1. If this is false, then return n2. This is logic to return the minimum value out of the both of them. So if we get n1 less than n2 as true, then return the value of n1. We are developing logic by which the minimum value is written, and if this relation is false, which means n2 is less than n1, therefore we would return n2 in case of false. So let us have a look at it again. We get answer as 14. Now suppose if I change the value to 3, in this case we would get minimum value as 3. We get answer as 3. Another thing we have to make sure is that the data type of the variable on left should match the type of data written by the ternary expression. In this case we are returning integers, therefore the data type of ANS is int. If the value returning is of floating type or real number, then we have to make sure that the variable on left is of type float or double. If it returns boolean value, then we have to declare the type as boolean, and if we return character or string, then we have to change the data type accordingly. Let us have another look from previous video. This was arithmetic operator video. In previous videos we saw about this example where we have 5 arithmetic operations. We have arithmetic plus, arithmetic modulo, minus for subtraction, multiplication, and for division. Now here comes the concept of compound operators. Compound operators are basically the shorter syntax of performing arithmetic and bitwise operations. The operations which we perform by arithmetic operators could also be performed with the help of compound assignment operator. Compound assignment operator supports 5 of all arithmetic operators as well as the bitwise operators. We are yet to have a look at what bitwise operators are. For now, let us have a look at arithmetic ones. We have declared two variables v1 and v2 initialized to 15 and 10. v1 plus equals to 30. We saw 5 arithmetic operators: plus, minus, multiplication, division, and modulo. Same way, compound assignment has its own 5 version: plus equals to, minus equals to, asterisk equals to, slash equals to, and modulo equal to. These are the 5 compound assignment operator. And also we have compound assignment with bitwise ones too. So we could have and equals to, or equals to, not equals to. We will have a look at it later on. So how compound assignment works is, the variable is for the case of plus equals to, the variable on the left is added to expression on the right, and then the evaluated expression's value is assigned back to the variable itself. So v1 plus equals to 30 could be simplified as v1 equals to v1 plus 30, which means add the value 30 to v1 and then assign it to v1 itself. If I say v1 divide equals to 10 into 3, in this case we have an expression on the right. So the expression would be evaluated as v2 equals to v2 by 10 into 3. First consider v2 into the expression on the right, divide the expression with v2 and assign the simplified value to v2 itself. So let us have a look at the output. Java C compound.java. Java compound. Here the value of v1 is 15. v1 equals to v1 plus 30. The expression on right would be evaluated first. v1 is 15, so we get simplified value as 45, which would be assigned to v1. So we could get new v1 equals to 45, and the value of v2 is given as 0. v2 would be evaluated v2 equals to v2 by 10 into 3. Now v2's value is 10. 10 divided by 10 into 3. 10 into 3 simplifies to 30, and 10 divided by 30 would give us 0.3 something value, but we have used the data type as int, therefore the real part would be truncated and we would get just the decimal part, the integer part, which is 0. Therefore we get the value of v2 as 0. Thank you.